You know what I'm talking about. That's a bunch of bologna sausage. Okay, as I teach to 20% of my seventh hour, um, is that about right? One, two, three, four, five, six, seven, eight, nine. What's 9 divided by like 27? 9, 18. No, let's not do 9, 18, 27. That's one third. There we go. One third of my class. Your test is Friday. Couldn't care less. You made a choice to miss today, most of you, and hopefully that water park is fun. But maybe in between water slides, you watch this video and make sure that you know what you're doing. Really not going to be too bad though. We got Monday and then Tuesday going to extend a little bit on 7.5, and then we're kind of done. So you guys that are here, you'll just be able to solidify the concepts. So the other people that have made the choice not to be here need to get ready by Friday, whatever way that means. Um, so hopefully we finish strong, just like that last quiz that we had. Blah 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 blah. And actually, this first one is not new, so it does say 7.5, but it's really not. You already had this. Who sits there? I'm sorry, in this front row. Oh, it's Julia. Me, Julia, pulling the rope, and then the thing flying. Right? Remember the two forces acting on an object with the rope tied to it. So really, you should be able to draw this right off the bat. The only difference with this, had a real problem with my pen today, but hopefully it acts up a little bit better. The smashing it on the computer is actually, there we go again. I really don't think it's a battery issue. I think it's a computer pen connection issue that I've had all year long. But anyway, two forces of those newtons act on a point. There's the point. The resultant force is 786. That's a bigger force, so the angle probably is kind of small in between those. All right, you want to complete the parallelogram to actually draw the resultant. That's the flying of the object, and that's 786. Move over here for you. But I do like having the screen showing on the video that I'm presenting of myself here with my sock shirt. Uh, you should know that the angle between these two forces is this angle, but really what you need to find is that angle. Because what's the relationship between the green and the red? Starts with an S. Supplementary, I heard someone whisper. And everyone should know that about parallelograms. Plus, we've already had these questions. Problem with this angle is it's cut up. You know, it's not cut up, but it's interrupted by that resultant. So I can't really find that. I want to find this angle and then just do 180 minus. Okay, so flash across the 423 and then concentrate on just this triangle. Just this triangle. That's an SSS scenario. To find that green angle would be the law of cosines. I do have my calculator ready. So we'll call this, I guess, x. I don't know, just to give it some sort of value. Cosine of x, then go back to red, equals, remember the law of cosines. Really easy. We're very successful last quiz. What does this end with? Who do we subtract? What's the last side? 786. That's why I do that, okay? Just to remind you what the formula is and how you kind of trick yourself to memorize it. It's minus the side opposite the angle. Okay, then it's the other two squared. So it's the Pythagorean theorem parts of the cosines formula. Then we have that 2 times part, and it's 2 times who? Every side other than the 786 we should have memorized. And then just because of time, all right, fifth hour, sorry this took too long. It took me a long time to type these on this calculator. Made a calculator error as well. But I'm just going to go up and show, bless you, how you make sure you type this correctly. That went too far. That's from last week. I did not use my fraction button. I literally worked with a senior on their calculator last week, and they realized, what? I have a fraction button after all the time that we've been in here together. Yes, there is a fraction button when you hit second y equals, and it's that 1. And then you could type this as a fraction without having to worry about order of operations. But you know what? I don't know how I get out of this. I don't want to lose my. There we go. I'm still up there. Darn it. I did go back all the way to the beginning. But without that, then you can type the numerator in parentheses and denominator in parentheses. So that's what I did old school. If you don't have an upgraded calculator, some of you have older calculators which still function great, the TI-83 and the TI-83 Plus. You have, what is that? Oh no, you have an upgraded one. Look like the Plus with the silver edition. Numerator parentheses, denominator one parenthesis. Don't use parentheses for times. It only jacks up things. And then you inverse cosine that ratio. So again, probably over explained. I shouldn't have to explain this at this point, how to type in the calculator, but let's try to get some more people on the bus of being able to get these answers correctly. Sorry, I lost that answer. 86.1. Don't lose yourself in the question. 86.1. That is this angle. So I need to find that red angle. What is that? I actually did that on the calculator. I won't bother you today. 93.1. Okay, so 93.1. All right. Okay, so now this one is right out of the book, and it's a little different. Same question, but little different things given, and luckily you get a picture for it. So you just get to look at it and listen to my explanation. If there wasn't a picture, you'd have to get this going. So a force of 176 makes an angle of 78 with another force. I don't feel like saying the minutes. The resultant of the two forces makes a 4110 with the first force. So here's the first force, 176 is given. Here's the second force, which I do not know, which I'll call X when I go to solve for it. The resultant, okay, let's complete the rectangle. Sorry, it's a parallelogram. I've said rectangle a couple times today. I don't know why. Um, and then understand that the resultant and the first force make a 4110. All right, so it's given, but you should be able to draw that and understand it's one of these scenarios. Okay, first things first, simple math. Let's do something, not nothing. Let's find this other little angle. And the relationship between that angle and 4110 is they should add up to 780 or 7850. This is perfectly ready to do grade school subtraction, if my pen would allow me to. It's real scratchy. 50 minus 10 is 40. 78, 68, 58, 48, 38, 37. So this is 37, 40. Okay. Now, the reason I would do that is I did something a little bit longer in fifth hour, and it took too long, but it still was correct. But why do I know this is 3740 then? What kind of angles are these with parallel lines and stuff going on there? And the answer is they are alternate interior angles. So that's why I flashed that to the other side, and I know that angle must be 3740. And then I should have done this first, probably. I should have done, what is this angle measure? And actually, what's the relationship between that and that? Starts with an S. Supplementary again. So I could have found that big angle measure by 180 degrees. You know what though? I'm going to write 180 degrees as 179 degrees in 60 minutes. Just like 2 hours is 1 hour and 60 minutes. 180 degrees is 179 degrees and then another 60 minutes. What I'm doing is grade school borrowing. It really is. It does reduce itself to, oh, my broken arm, Lexi. Bummer. That's why I had to miss on Friday. We had to get her a cast, a permanent one. Her one that they gave her on Thursday wasn't very comfortable. So it was either I get her at Friday or today, and I didn't want her to go through a weekend of pain. So that's why I had to miss super quick on Friday. Um, told last minute that you come in at 11 or it's Monday. So I had to come in at 11. So flipping this to the other side, this is 101.10. And now I have three angles in this triangle over here. And that's what I'm going to focus on now. This has now turned into a 7-1 question. It really has. Now I have an angle with all three sides and, I'm sorry, with all three angles, my bad. I have a triangle with all three angles and one side. So what law can I use for that when I have to find the resultants and this other force? The answer is law of sines. I'm going to put this as x here, flash this across because these are equal, but I'll find the resultant first. Sine of 3740, because 3740 is opposite this given side, 176. And that equals, if I'm going to find the resultant first, it's sine 101.10 over r. Okay? And then go to my calculator. And I did do that next. Here we go. How do you do sine of 101 and 10 minutes? It's 101 plus 10 divided by 60 because there's 10 minutes. There's 60 minutes in an hour, 60 minutes in a degree. Same conversion, same idea there. And we should know that we have to cross multiply there. So it is 176 times sine 101 divided by sine 3740. You should understand that cross multiplication at this point. This is not new. This is exactly what we did in section 7.1. So there's the numerator, multiply, divided by sine 37 plus 40 over 60. And then final answer is 282.6. So R is 282.6. And this is in pounds this time. The old English, not metric system, newtons. I think newtons are in metric. And then same setup again, sine 3740. You know the power of the law of sines. Equals sine. Okay, and that is opposite 4110. Sorry, lost myself for a second. Actually, lost myself in thought over something. Trying to do two things at once. And I think someone told me it was 189 point something. I forgot what it was. If you guys want to tell me what it is, that's fine. If you don't want to type it, that's okay too. That one I didn't type, but I had fifth and sixth hour tell me what the answer was. So randomly, because they gave me information about those singular angles within this situation, it actually turned into a law of sines question. It really depends on what's given and what you can do with that. So kind of interesting. No one typing? I don't see anyone typing in this class, so I'll just move on. I know it was 189 point something. I think it was 0.6. Yep, there we go. 0.6. Nice. Thank you. That's pounds. All right. Now, I stole this off the internet. We do have to add some stuff to this, but here's the next new question. How many people are in physics of the 9 people that are in here, 7th hour? Nice. You should remember this. I thought physics people did this ramp thing and actually, back in the day, remembered it as a specific formula. I'm going to make you make the drawing. Making the drawing's 2 points. Final answer with trig is like 1 point. Well, maybe be 4 points total, but we'll see. So want you to make sense out of this, and it actually is very easy to make sense out of it. It's all basic geometry, and that's what I hope. Unfortunately, I don't know if the geometry is all there that we need. So hopefully this makes sense. And you could read this off to the side. I'm going to zoom in on the picture. What you have is pulling things up a ramp. A real cool question in the homework about the pyramids and what they actually think did happen for them to get these blocks that were tons and tons of weight. The force applied in order to get those blocks put up in the pyramids and stacked. It's actually amazing engineering. But here's the first thing. Weight pulls straight down on us. So the weight vector right here is perpendicular to a horizontal on Earth. You need to draw that right angle there. So when we construct this ramp question, with the forces applied here, We got to have the angles in the right positions through basic geometry. Okay, and then this is what's happening. You're trying to pull something up a ramp. So here's really where the force vector belongs. But then they've already applied in this drawing the idea of a parallelogram. So, okay, as a parallelogram is concerned, that force vector could be considered to be down here if I completed the parallelogram. And that's what this is. It is a parallelogram again. But the dotted line kind of might mess you up a little bit. It's parallel to the weight thing, but just so you know why that force vector is down at the bottom. It's really the force being applied on the ramp up at the top. Whether it's being pulled or pushed, it doesn't matter. That's the direction we want to go. All right. But then what's important is what I call, let me change that to green, the ramp vector. And I don't think that's listed in this little thing that they're talking about. The ramp vector, that is perpendicular with the ramp. That's why it has a different shape or different, it's going in a different direction than the weight vector. That's important because obviously, the higher the ramp, the harder it is to pull something up the ramp. And you'll see in the in the Egyptian pyramid example, the ramp is like super, super small. That means the ramp had to be very, very far away, and they had to push those blocks like miles in order to get to the top of the pyramid. That's the only thing they think with the technology involved in the day that could have happened. Or if you watch Ancient Aliens, they think aliens did it. Anyone ever hear that show? Oh, you kids. All right. Ancient Aliens is kind of a funny program that they believe some things in the past were there that we don't know about. Hey, by the way, that makes this a right angle. Why? These angles, again, as mentioned earlier today, are alternate interior angles. The F's are parallel to each other. These are inside that. And I'm sorry, I hit that in the wrong spot. My bad, dogs. Roof. That is completely and totally disconnected there. I was thinking about aliens and I got my mind all messed up there. That is right there. See, those are connected by this transversal here. The ramp vector. So my bad, dogs. I wrote that wrong at the first point. And that what I just did there is a common student mistake, putting the right angle in the wrong spot in the this force triangle, the triangle that I need in order to solve this question. So even though we get this thing off the internet, you need to understand where these right angles are. And then once you do, this question becomes really easy. Okay, one more thing. Now, hopefully, I'm going to color code this. This worked out real well, 6 hour. All right, you should know that, okay, we assume that the ground is flat. So when we're ramping up to some object where we're trying to get this to, this is a right angle. That right angle is assumed. I can approach this a couple different ways. I'm going to do this through similar triangles. Take this triangle and take this triangle. Wrong. There we go. These two triangles are similar then by AA. They're both right angles in this corner, and they both share theta, that theta right there. So with those two triangles being congruent, wrong, similar, I'm pulling the wrong things out of my head, those two angles must be congruent. Or you could say these two are vertical lines and those are corresponding angles. Couldn't care less. Now, very simple thing. What are three angles in a triangle? What do they add up to become? 180. What do these three angles add up to become? What do these three angles add up to become? 180. That's a straight angle. If you can see me in the video, I'm trying to identify this thing as a whole angle from here all the way to here. That is 180. So if these blue, green, and theta add up to 180, right angle, green, blue, that angle right in there must be theta then. It must be exactly the same as what the ramp angle is. And that is always the case. So through simple geometry, this is what the result is of a ramp question. That triangle with the weight vector and the force vector, the ramp angle is right in this little triangle as well. Okay. So with that being said, I love their first question, and the only reason I'm not going to do the second is because we're going to do questions with this later. I don't want to make this an example. So what's true and verify this? Well, look at this. I have a right angle, and what side is this? What side is that? Opposite, adjacent, or hypotenuse? I don't have the time. Opposite. And then what side is this? It's opposite the 90, so what side is it? Hypotenuse. So someone said adjacent. Hypotenuse is always opposite the right angle. Okay, so what deals with opposite and hypotenuse? Sine. So sine of theta would equal force divided by weight. And then all you'd have to do to turn it into this formula is multiply both sides by weight. So force equals weight times sine of theta. And I thought back in the day that was just a formula you were handed to in physics for ramp questions. And then did more with it from there. For the math part, we try to simplify it through simple geometry and then show you the simple breakdown of this question. So go ahead and look at this first question. Everything coincides with everything I just covered right there. And I'll reiterate it as we look at this drawing. But this is why we ask these kind of questions. What's the force needed to just hold it still? All right. And then the idea is, all right, if we increase that force, then we'll start pulling it up the ramp. If we decrease the force, it's going to start falling down the ramp. What's the point of maybe what I would call equilibrium? So find a force to keep a 50-pound wagon from sliding down a ramp inclined at 20 degrees to the horizontal. This is a big assumption. Assume there is no friction. Even in a wheel with wheel bearings, there is still a little friction. There is still a little resistance, but it minimizes it almost to zero. And then you talk to a physics teacher about, what that is as far as how that would affect the situation. We're assuming there isn't. Here you go. Weight vector. Notice it's a right angle to the horizontal. Force pulling up the ramp, flash it across to make a kind of a parallelogram, but I don't want to complete the parallelogram. This is equal to this, all right? And we'll just leave it at that. Ramp vector is a right angle with the ramp. That's why it goes in a different direction than the weight vector. It's the, it's the, what do you call it? The conflict with the ramp, what's causing the issue. The more the ramp is, the harder it is. That's what that vector really decides. And then notice again, here's 20 degrees for the ramp. Here's 20 degrees inside this triangle right there. That's what's true, and that's what you're going to have to remember. And then one more thing you're going to have to remember, alternate interior angles. That's why this angle is the right angle, not the one that I accidentally identified myself and the biggest mistake that students make. Once this is done, here's F, and you can simplify this yet again into a math 2 question. It's sine of 20 degrees because F is opposite and 50 is the hypotenuse. That's as simple as it gets. And the force is 50 sine 20. And then I forget already. Could someone just click that real quick? I forget what that actually is. Fumble. 22.9? Yeah, I didn't think 22, but 17.9 sounds about right. And just from memory, sorry. And I think it's in pounds because we have the weight in pounds. Right? So that's what we'd have to say. So 17.9 pounds of force would hold it there. If I increase it, then I could start pulling it up the ramp. Back in the day, do you know what the force was to push the blocks up for the pyramids? Humans. All right, and that's what was tough. You probably had people pushing. People had pulling with ropes around it, and the amount of people that you would need. I remember doing that with that question, trying to say, hey, say the average person had this amount of force. How many people would it take to move this 60-ton block based off of this question? It's kind of interesting to think about what they actually did to create that. Okay, is that what your question says? Does yours say number 7? Yes or no on your notes? No, at home it does. I made the change, but I printed and then I said, you know what? I want one where you have to find the angle. So go ahead and make that change real quick. And then sorry for those watching the video, if you are in between the water slides that you're doing. Um, I'm going to have you also draw this on your own. So I'm going to freeze the screen if I don't choke myself with this. Go ahead and change your number 8, change it to number 7 from out of the book, and then go ahead and do it. I'm going to freeze the screen and make my own, at least make the drawing based off of what we just said. You guys online will see me go ahead and do this. Okay, first things first, you got to draw the ramp, but I'm going to make mine real long and lengthy here, so the triangle I concentrate on is the force and the weight one. So here's the weight. Remember what that's a right angle to, and I don't care where you start on the ramp. I like starting here just because of space. That's right. And then here's the force, and then I'm going to go ahead and zoom in on my triangle here. That's 25 being pulled up. So flash that across to kind of have your parallelogram, but I'm not going to complete it. Okay. And the one thing that's missing is your ramp vector, and that's okay that I missed it, doesn't matter. That's a 90. Alternate interior, that's a 90. And then what you're trying to find is this, through my long, glorious explanation, that is equal to that. It's over. It's as simple as it is. This would be like 2 points on the test, and then maybe 1 or 2 points for setup and answer. Quite simple. Ain't no thing, chicken wings. There goes my pen. There, now we're starting to get, computer's just starting to do its thing. Oh, what a year. Pen issues, COVID, students missing, students wanting extra points when they're missing. It's all great stuff. Okay, so unfreeze in class. And we get an answer? Is that what you got? Sine of theta equals 25 over 80? Huh? Okay, you could probably just remember that, but I'm counting 2 points for the drawing. If your drawing isn't kosher compared to the question, that's the point of the mathematician part of it, how you simplify it to simple geometry. What's the final answer? Sorry. No? No one typed it? Inverse sine of 2580 over 80? 18 point what? Degrees. So make sure, and not saying you didn't say that, saying make sure you label this at the end. That's what you were trying to find, the angle measure in question in this. But again, one more time, the weight vector, oh boy, I might have to go to my thing to finish off at least the other notes. And you don't have to listen to this next part, but I'm giving those that didn't do anything Friday another chance. But you might want to watch the synthesis of 7.4's notes again. So I had to come here and, oh, cool. Kind of see the screen nicely. How come I can't get my, there we go. Move my fat head out of the way. Okay, any questions on that? All right, you may or may want to may or may not want to listen to this, but I synthesized Friday's notes too. So I actually had a plan. I had this created, and then I got I had to go get Lexi taken care of here. So I had this planned where I was going to do a couple of these from this. It emulates 5 and 7 from your homework real quick. The whole front page of Friday's homework was all review, but then I threw this linear combination method. And sorry that the notes don't say that, but all 3i plus 4j translates to is 3 comma 4. So don't make a big deal about it. It's not really that hard. I tried to break down the reason why, and just so you know, we're only doing the basics of vectors. When it's in that 3i plus 4j form, it makes it nicer to work with, and that's why they created this format. It almost makes it like algebraic in nature. So I was going to do this one. I'm not going to bore you. This was on our previous set of homework. It was review. I just wanted you to know that this is the same as -6 comma 10 That's the only thing you have to read out of this. It's not a big deal. This is the same as negative 11, negative 1, meaning those are the endpoints of the vector with the beginning points being 0, 0. But to find this, you might just want to leave it like that. And then you know what you could do? Negative 5 times f. You could then hand this to a freshman and they could continue the problem. It's really a true story. Because really what this turns into is just the simplification of an expression. So that IJ format allows you to work with vector operations a little bit easier. Now, is it necessarily easier? But in other cases it is. And I just wanted you to know that. But for your purposes, this is not a big deal. This is not a big deal to make that translation and then go from there. It really isn't. So just take that to heart and then move on from it. And then, like I said, you could hand this to a freshman, and they could simplify this further as long as they distribute the negative, right? Okay. So got that taken care of. Next thing, just get this down. What's dot product? It's a very strange thing. And what does it do for you? The only thing it does for you is the next formula. That's the only thing that I could see that's practical about it. And just understand that this is the x's multiplied together. This is the y's multiplied together. It's really all it is. And then you add those together. And then that's used in our next formula. But just to do dot product real quick, and I did this on Friday if you watched the video. Unfortunately, I know when I'm not here, some students, when the cat's away, the mouse will play. They don't do anything and then blame the teacher for their shortcomings. Love it. Love it. Hey, and then this one, this is 0i minus 1j. So this translates to 0 comma negative 1. Okay, so just so you know that, to do the dot product on this one, this is 2 times 0 plus 4 times negative 1. So yeah, it's another weird formula, but is it difficult? Not really. All right, try to remember dot product just ends up being a sum of two different things. All right, and then this is the only use I could see with dot product. And this is actually related to the law of cosines. There is a big, long explanation of why this is the angle between two vectors things. I read it and I can't say I understood it all the way through. I just that's too much. I would never share that with class. So just accept this formula. It's one of those times. So cosine of theta equals dot product divided by multiplication of magnitudes. And I explained that much further in the previous video from Friday. So this is all you got to worry about. And you know what? I think I did this in the video and it's worth doing. Then on your homework, I gave you questions where they had the graph. And I really appreciated those and liked those because you had an appreciation for your answer. Your answer, therefore, made a little bit of sense. The angle between these two vectors should be very small, right? That's the only reason that I graphed that. Are you sleeping? Oh, okay. I thought maybe you were sleeping. I know my voice has a melodious tone to it that makes you. Come on. Come on. Come on. I just have a couple more. Thanks, Pen. You're so helpful. Cosine of theta, 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 theta. Let's try that again. Theta, theta, theta. Yay. Dot product. Whew. This pen will be the end of me. I only got 1 week left. 4 times 1. That's simple. Down at the bottom, it's magnitudes. The magnitude of this is just the Pythagorean theorem. The magnitude of this is just the Pythagorean theorem. The top is 6 plus 4, which is 10. 10, 10. Here we go again. That's not working so much anymore. Really bad, 6th hour. We were flowing pretty good here. Now the pen's acting like a jerk again. 10. All right, this is 25. Square root of 25 is 5. Nah, I shouldn't have to teach that and say, where'd you get that from? 2 squared is 4 plus 1 squared, 5. That's the square root of 5. Much different. All right, and then I'm going to go to my calculator. I already typed this in. And this time I did use the fraction button. I screwed up the first time. Error. There it is. 10 divided by. This you don't have to do order of operations then when you use that fancy fraction button. But then you inverse cosine. 26.6. You should know at this point that this is an inverse cosine question. 26.6. And my pen's a jerk again. Theta, come on. And waste so much time with this pen. It's frustrating for you guys too, especially when found out tapping on the screen. Oh well, I'm done. I quit. Quit writing. It's ridiculous what I have to go through here. So 26.6. Again, a small angle measure, which is what I expected there. That's why I like those questions with those. And the only thing I was going to write here is I'm not doing this one, and I didn't do it for any of the other hours. I was like, I gave up, just because it's overdone at this point. But what's orthogonal mean? Starts with a P. Perpendicular, actually. So, oh, I knew I had the. So orthogonal means perpendicular. So basically, come on, Penn, you can do it. You came back to me. You do the same thing you did here. If you get 90 degrees, it's perpendicular. By the way, something funny. If you get 0 degrees between the two vectors, it doesn't mean they're the same vector because one's longer than the other. What you actually say is they're parallel. Imagine if the angle between two vectors was 0, one would be like this, and then one would be like this, maybe longer. Since they have a longer direction, you actually say they're parallel because they're going in the exact same direction. And then say you got 180 degrees, which I think happened on maybe some of yours. I don't know. That means they go in opposite directions. So they're not parallel, they're not perpendicular. They actually go in directly opposite the direction. But going back to this, some person decided when vectors are perpendicular, they made up this new word. So I'm asking you to remember one word in this chapter, what orthogonal means when I ask that question. So just make sure you know that. Okay, now we're done. And for you guys, we only have one more